let us integrate tan inverse of x. Again, we're going to use integrating by parts. So I've started with an substitution. So I'm letting tan inverse of x as t. Okay, so when tan inverse of x is t, I can write x is tan t, and differentiating with respect to t, dx by dt is tan inverse, sec squared t. Okay, so I can write dx as sec squared t dt. So what we can do is, we can, in place of dx, I can put sec squared t dt, and in place of tan inverse of x, I can put t. So this is what I've written. So this implies tan inverse of x dx changes into a t form, that is t times tan t times sec squared t dt. So this dx is changed to sec squared t dt, and the tan inverse of x is t. Okay, so now we're going to do integrating by parts. So this is how you set out. So well, we say that let f of t is equal to t if f of t is t and g prime of t is sec squared t. So these are the two functions. So integrating by parts, you have two functions where the first function, one of them you take as f of a function, the second as a gradient function. So g dash t or g prime t is sec squared t. So here we are integrating and here we are differentiating. So when you differentiate t with respect to t, you get 1, and the integration of sec squared is tan t, because the differentiation of tan is sec squared, so they are opposite of each other. And this is the formula of integration by parts, that integration of f of t times g dash t dt is f of t times gt, g of t minus integration of f dash t times g of t dt. Okay, so I have to just substitute the values. So this is f of t, which is t, and g dash is sec squared, is equal to, cross multiply this two. Okay, so that's what you do. Multiply this two minus the integration of this two. It's, if you set out like this, it's easy to remember. First you find the derivative, sorry, the integration of this two is equal to the product of this two minus the integration of this two, or the product of this two. That is f dash t is 1 times g of t is tan t. Okay, so the integration, we have to look up integration of tan t, and tan t can be written as sine t over cos t. Now you should know this formula, integration of f dash x over f of x dx is natural log of f of x plus c. Okay, so if you, the derivative of cos is negative sine, so what I've done in the next step is I've taken this negative and put it along with minus, or put it with sine. So this is minus sine t, and so I have to put a plus here. So where now what has happened is, this is f dash x or f dash t, and this is f of t. So the numerator is the derivative of the denominator. So that ends as natural log of cos t plus c. I'll remove this now, the whale. So this is the answer. Now explain how from here you can get this. So uh, so let us can understand till here. To understand these two steps, I'll go over these steps first. So we started with that t is tan inverse of x. So if t is tan inverse of x, this implies, from this we can say x is tan t. So x squared is tan squared t. And I'm adding 1 to both sides. So 1 plus x squared is 1 plus tan squared t. And 1 plus tan squared is sec squared. So I can say 1 plus x squared is sec squared t. and taking the reciprocal of both, so 1 over 1 plus x squared is 1 over 6 squared, and 1 over 6 squared is nothing but cos squared t is 1 over 1 plus x squared, and taking square root, I can say cos t is 1 over square root of 1 plus x squared. So in place of cos t, that's how I wrote this, t, tan t is x, and t is tan inverse of x. That's how I wrote x times tan inverse of x plus natural log of 1 over square root of 1 plus x squared. And here, natural log of 1 over square root of 1 plus x squared is nothing but natural log of, I can write this as 1 plus x squared to the power negative half. Okay, and applying the log rule, this half can be multiplied with, and that's how I got this negative half. Okay, and that is, the square root will be removed. So this is the most simplified form of the integration of tan inverse of x.